Okay, welcome back in our mathematical technical workshop. We are still proceeding with our three-dimensional figures, episode 1, and today we are going to see examples based on the pyramid concept. Let's see a question. A figure below is a square pyramid. The base has sides 8 centimeter. Point V is the vertex and the edge AV is 12 centimeter in size, and that's AV equals to BV equals to CV equals to DV. As you can see now, the pyramid, the square pyramid is shown. Now we are required to calculate the following. The height of this pyramid, the angle between the HAV, and the base ABCD. The angle between the face VBC, as you can see, and the base ABCD. Also, case 4, the surface area of the pyramid, and lastly, the volume of this pyramid. By starting with case 1, we are required to calculate the height of the pyramid. We know the height of the pyramid from the vertex of the pyramid V, it is directly perpendicular to the center of the base. So the center of the base from the question is not shown. So what we do, we are going to develop the diagonals of the base. Now the diagonal of the base itself is a square, so it has 4 sides. It means we have 2 diagonals. As you can observe here, the diagonals AC and the diagonal BD. So where the 2 diagonals intersect is where the center of the base is. And now this V now, from the vertex V, we develop a perpendicular line VO. So VO is perpendicular to the center of the base O, as you can see here. So it means VO is our height of the pyramid or the altitude. Now from triangle ABC, we need to know the dimension of one of the diagonal AC. So from there, we can use this triangle ABC, as you can see here, by Pythagoras theorem. AB square, when you plus with the B square, equals to AC square. So 80 square plus 80 square equals to AC square. And when we try to operate the terms, AC square equals to 64 plus 64, which result to 128. So when you square both sides, when you square root both sides, AC will be equals to 80 radical 2 centimeter, which is less more to 4, which is less more to, yeah, it is 80 radical 2 centimeter. But what we need here, we need the half of the diagonal AC. So AO and the OC together is the same as, say, diagonal AC divided by 2, as you can see here. 80 radical 2 divided by 2, we get 4 radical 2 centimeter. Now, because H now is found on VO, the line VO, it means we take the triangle VOC, as you can see here, but whereby the dimensions are VO is H, and the OC is 4 radical 2 centimeter, and the VC is 12 centimeter. So by Pythagoras theorem, again, because this is right angled triangle, then OV square plus OC square equals to VC square. So we plug now the identities, like OV is H, so it'll be H square. You plus OC, which is 4 radical 2. Now we put square equals to VC, which is 12. Now it'll be 12 square. Now on operating, we'll have 12 square is 144. We minus this much will be 32. Then H square is less more to 112. Now on squaring both sides, on square rooting both sides, we'll have H equals to 4 radical 7 centimeter, which equals to 10.60 centimeter. And there now we can say the height now of this pyramid is less more to 10.60 centimeters. Now case 2, we are required to find the angle between the line AV, and the base ABCD. Yeah. So by starting now, we need to find the angle, where the angle lies. So what do? We can use the technique of projection. So for example, the line AV and the base ABCD. So this is just the base or the plane, and this is the line. So what we do, The first step is to find the common point of intersection between the line and the plane. So as you can see, point A is found on both line and the plane. So this will be now the point of intersection, which is here. It means this indicates that the angle will lie at this point. Now from there, we go back to the line. Now we find the point V is the point that remains on the line. So what we do now here, we are going to project this point V on this plane, ABCD. How do we do that projection? We just place a torch overhead point V so that its shadow will fall on the base, on the square base ABCD. Now the shadow V will fall on O here, as you can see here. So will fall on the point O, which is the center of the base, and whereby we have VO, which will be the normal line to the base ABCD. Now from there, we are going now to find the projection of AV. So we join the shadow of point V and the point of intersection. So we join O and A. We join O and A, as you can see here. Now when we join now, we'll have the line OA. This line OA now will be the projection of VA on the square base ABCD. Now from there, here we are going to develop a triangle VOA. So the angle formed here, the angle formed equals to it's just angle VAO. VAO, or we can say OAV. The angle is here. And now, by definition of the angle between a line and the plane, the angle that is formed between the line itself, the line AV itself, and its projection on the plane. Its projection is AO on the plane ABCD, as you can see here. So this is just the projection of the line AV, and the line itself is AV. So the angle is between the two lines, this and that one. Now, from triangle, so for we to find out the size of the angle, we just take the triangle which has the name with the angle. So from triangle VAO, a right angle triangle that we can draw here. So right angle is at point O, the center of the base, and here it's V, and here C, point A, the point of intersection. So the angle is here. Now the dimension now. VO we calculated from case 1 here, and we got equals to the height, which is 10.6, which is 4 radical 7 centimeters. But also OA, we calculated this is half the diagonal AC, which was here 80. It was 4 radical 2, which was here 4 radical 2 centimeters. Now, from this right angle triangle VOA, we have two sides which are known, and we have the angle now. So we can apply the concept of trigonometric ratio, that angle A, angle theta here, is opposite to 4 radical 7 centimeter, and here will be the adjacent side. So opposite to adjacent, that is tangent. So from the tangent function, or trigonometric ratio, tangent, from trig ratios, that tangent tan of theta equals to opposite side to the adjacent side. So now tan theta is less more to opposite is 4 radical 7 centimeters, to the adjacent side is 4 radical 2 centimeters. Now on simplifying here, we'll have radical 7 over radical 2. centimeter and centimeter will cancel out, 4 and 4 will cancel out. So what's remain here, because the two numbers 7 and the 2, the discriminant, they share the same index, so we can have like 7 over 2. Then from there, now we can simplify by using our calculator here. And now we can have like, so it's radical of 7, now divided by 2. Now this equals to, radical, so radical of 14 over 2, which equals to 1.88708. 4 figures. We just find 4 figures. So here, remember, we have tan theta. Now for we to find theta, we need to find tan inverse of this figure here, or the arctan of the figure. So theta will be equals to tan inverse of 1.8708. So when we calculate, now theta will be less more to what? Now from the calculator now, yeah, tan inverse of, now this is less more to 61.87, yeah, 485. Oh, when we express in degrees and minutes, it will be 61 degree by 52 minutes. So therefore, the angle between the line AG, angle between the line AG and the base ABCD is 61 degree by 52 minutes. Yeah. Okay, we are proceeding with our case 3. The angle between the face VBC and the base ABCD. You can see all these two faces, it means they are plane. Why? Because we have more than 2 points. You can see here we have 3 points, so we have a face, triangular face, and here we have 4 points. That means we have quadrilateral face. As you can see now, VBC is here, and ABCD is here. So the two faces. Now what will be the angle that is formed between the two faces? So the angle between the two planes, or the two faces, is the angle that is formed at the line of intersection where the two planes meet. And this angle is formed at a point that is formed on that line of intersection by the perpendicular lines from each plane. So the first thing we need to develop the angle, we need to see where the angle now is formed. By doing solving strategy, we started with we write the two planes. Maybe this is plane 1, and the plane 2 now is ABCD, that is plane 2. Now we form the line of intersection, between the two planes. How? We try to find the common point between the two planes. As you can see here, point B is found between the two planes and the point C. So the line BC, you can observe now from the figure, BC is the line that's where the two planes now meet. So we can just extend, by dotted lines, so as we can observe it properly, BC. Now from there, after having now the line of intersection, that is BC, we go back now to our planes. What do we do now? For example, in plane 1, we have the remaining point, which is V, and in plane 2, the remaining point, which is AB. So what do we do? Now we are going to use the one technique. This is the technique that will help us to form or formulating the perpendicular line from each plane. One means the long form of it is which one among the given point is nearest to. a certain point. So now here we have V, we have BC. We want to develop a perpendicular line at this triangular face to the line of intersection from point V. So you ask yourself, between point B and C, which one is nearest to V? Or V is nearest to which one between B and C? You can observe that VC and VB are the same. That's VB equals to VC. These are slant edges. So everyone, VC and VB, everyone having the same distance to the points. So what we do, it means the point that will be very near to V, it means the point that will happen, or the midst of B and C, the midpoint. Maybe we can place it here. So the midpoint of the line segment BC, maybe we just put M here. This one now will be very nearest to V, as one technique needs. So here, now, because BC was 8, it means here will be 4 centimeter, and here will be also 4 centimeters. 4 centimeters in length. That's make a total of 8. So now we develop a line. Now we'll have a perpendicular line from V to the line of intersection at point M. So the line now will be like this one. Now this will be our line and is perpendicular. As you can see there. This is perpendicular to the line of intersection BC at M. Now the plane that remains to give us the perpendicular line to the line of intersection is the line that is found now from this remaining point here, A and D. A and D. Now, because the first perpendicular line goes to M, it means from this plane A, B, C, D, also the perpendicular line, we know it will come from the midst of AD. AD, because this between AD, the midpoint here, will be nearer to the M instead of C and B. So also we develop a perpendicular line now from between A and D. Okay, so it will be like this. Okay, so here maybe you can call it a P, point P. So the other perpendicular line from the second plane to the line of intersection at M will be PM. Now the angle is formed between the two perpendicular lines, and it is here. And now we remember that we had our height, the height of the pyramid, which we say it was VO, and the VO we can just place it as here. That is our VO, which is perpendicular to the center of the base. So having drawn up to that point now, we can have a triangle where the angle lies VMO. We can observe triangle VMO. That's the angle that now is formed between the two planes. Now, by proceeding now, so we say from triangle, so here we say the angle formed is angle VMO. That is angle VMO. And then now from triangle VMO, the triangle VMO, so we can just draw here. So right angle is here at point O, and here is M, and here is point V. Now coming back here to our figure, OM is half of PM, which is half of also AB. But AB, the dimension was 8 centimeter. It means OM is half of this 8. So here will be 4. So here the dimension now will be 4. So it will be 4 centimeters. Now remember to place our angle. And now VM is not the same as VC and VB, because this now will be the height. The height of this triangular face VBC, and note the slanty edge. So this is different from this 12 here. That the dimension of VM is not the same as VC. So we need to find this from the advantage of these what? Right angled triangles VMC or VMB. So here we don't know first. Then we come back to our VO. Yes, so VO, it is 4 radical 7 centimeters. So here we put 4 radical 7 centimeters. We calculated earlier in case 1. So now we have advantage of two sides, and we are supposed to find an angle. So this angle now is opposite to this side, adjacent to this side, and the hypotenuse. So opposite and adjacent are known, so we can use, say now, from trigonometric ratio. Now here will be tan theta equals to the opposite side dimension. We divide by the adjacent side dimension. So here opposite it is 4 radical 7 centimeter. Now adjacent is 4 centimeters. And I think OM here is half of AB. So that's correct. So tan theta now equals to, we simplify, centimeter cancel out, 4 and 4 cancel out. So we remain with the radical 7. Now theta equals to tan inverse of radical 7. So theta equals to, now from the calculator, our scientific calculator, shift tan of radical 7. This one now is less more to 69.3 degrees, or when we express it in degrees and minutes, now we're going to have 69 degrees by 17 minutes. So now the angle, the angle between the face VBC and the base ABCD now is 69 degree by 17 minutes. This now will be our angle. Okay, case 4 now, we are required to find the surface area of the pyramid. Now the surface area of the pyramid, as you can observe, our pyramid is here, VABCD, and now the surface area can be calculated by taking the summation of all the faces, the area of all the faces, starting with the base and all the lateral faces, when we just add the surface areas. So we can say surface area is given by the base area we plus lateral surface areas, because there are more than one, but in pyramid we have only one base. So base area, it means here will be the area of the square, that's the square area, because we are told earlier from the question that the base was a square. So the square, the area of the square, and we plus the lateral surfaces areas. So the lateral surface are the faces which are not base. As you can see, all of them are triangular in shape. So what do we do now? We can find, for example, starting with the area of the base. Which now is a square, area of a square, A, B, C, D. Now this equals to, we know the formula for area of a square, that is side length, you just time with the side length. So it will be like 8 centimeter we times 80 centimeters. So we are going to get 64 centimeter square. That's the base area. Now coming to the lateral surface areas. The lateral surface areas, as I said earlier, this refers to areas of the faces which are not base. I mean all these triangular faces. Now because the base is the square, it means all the lateral faces are the same. Yeah, as you can observe, like VBC will be equals to VCD equals to VAD equals to VAB. So they are 4 in number and all of them are congruent. So we can say lateral surfaces are, we have this VBC and VCD and VAD and VAB. So all these are lateral passes and all of them are the same. So better we find the area of one first, then we times by 4, then we get to know their total surface areas. Now from VBC, which can be observed from the figure here, we have the base BC, which is 8 centimeter in length, and we have this slant edge, which is 12 centimeter, but here now will act like hypotenuse of the triangle VBC. And now we developed here the height of the triangular face VBC, which was VM, and here now it's the height. So this now will help us to find now the area of this triangle. So what we do here, we consider triangle VMC or VMB. The two triangles are the same because they have commoners here, VM. So when we consider it, it means now we'll solve the value of VM, which will act like a height of the triangle. So from there now it is easy to find the area of this triangular face. So we say from triangle VMC, so the right angle is at M, and here now is V, and here is C. So MC here, it is half BC, which is 4 centimeters. Here is 4 centimeters. Now VC was slant edge, which is less more to 12 centimeters. And now we want this VM, which will be the height of the triangle. So by Pythagoras theorem, here we'll have VM, which is h, so we say h square plus mc square, which is 4 now square, equals to vc square, which is now 12 squared. So we'll have h square with plus 16 equals to 144. Now h square equals to 144, we minus 16. So h square equals to what? Now from the calculator, 144 minus 16, here will be 128. So on square rooting both sides, h will be equals to the square root of 128. It is now equals to 8 radical 2 centimeter or 11.3 centimeters. Now after getting this height Vm, now we can say from triangle this lateral face now VBC. Then now area of the triangle VBC will be equals to a half, you times the base of that triangle, we times the height of the triangle. So it is a half Now we times the base. So the base here is BC, which is 8 centimeter in length. So it is 8 centimeter times the height. It is VM here, VM, which we get 8 radical 2, 8 radical 2 centimeters. So when we simplify by 2, 1 here, by 2 it's 4. So we'll have 4 times 8 here, radical 2 will be 32 radical 2 centimeter times centimeter, centimeter square. So now coming back, when we simplify now, 32 radical 2, it is, I would say, it is approximately equals to 45 point, yeah, 0.3, yeah, centimeter squares, yeah, because these are the units of length. And then now we have one lateral surface area. So what next? The lateral surfaces are 4 in numbers, so, and all of them are the same. So we just multiply them by 4. So we say lateral surface areas equals to 4 times area of one lateral, which was 32 radical 2 centimeter square. So we'll have, so when we multiply by calculator now, yes, 2 here, so it will be 128 radical 2 centimeter square, or this equals to 181 point, yeah, 0.02 centimeter square. So now coming back now to the surface area of the whole pyramid, that's base area we plus the lateral surface area. So we can just place them here, like the base area here was 64 centimeters square. Now we add it with the lateral surface areas, which is 181.02 centimeters square. So when we add here, so we'll have, it will be 245.02. It will be equals to 245.02 centimeter squares. Or when you express in radicals, it will be like, so it will be a lot of numbers. Radical 2 plus 64 centimeter squares. So I think this will be the best. So surface area equals to 245.02 centimeter squares, and that will be the surface area of the pyramid. Okay, now we are going to case 5. We are required to calculate the volume of the pyramid VABCD. Now volume is the amount of space, and in pyramid, volume is given by the formula volume equals to the base 1/3 times the base area, we times the vertical height of the pyramid, or the altitude, the vertical height of the pyramid. Now here, our base ABCD is the square first with the dimension 8 centimeter in length. So we'll start writing the details. That's the length of the base equals to 8 centimeter. Now the vertical height of the pyramid, or the altitude, h, is less more to 4 radical 7 centimeters. Now starting with the base area, now the base area equals to the area of the square ABCD, which is given by the length of a side times the length of a side, or side length times side length. So our length here is 8 centimeter, we times 80 centimeters. So here will be 64 centimeter squares. Now coming back to the volume, now it is 1/3 we times the base area, which is 64 centimeter square, we times the vertical height. Here it is 4 radical 7. Vertical height should be perpendicular to the center of the base, where the two diagonals meet here at the point O. So it is 4 radical 7 centimeters. Now, on simplifying, so here 3 cannot divide 64, also cannot simplify here. So we can introduce 1 to the denominator of these numbers, so it's going to have fractions. So 1 times 64 times this much, the same as say 64 times 4 radical 7. Now centimeter square times centimeter, we get centimeter cubic. Now over 3 times 1 times 1, we get here what? 3. So now we are going to simplify by calculator now. So here we'll have 64 times 4 radical 7. Now we divide by 3. So we are going to have something, it is equals to is 225 point now 77 centimeter cubic. So therefore volume of the pyramid is 225 point, you can approximate here, and you can have 8 centimeter cubic. Yes.